Yes, the topic is about JVM, Java Virtual Machine. Okay, so before going to JVM here, yes, in your system, there is RAM memory, RAM and hard disk, RAM and hard disk, RAM and hard disk, RAM and hard disk, RAM, next hard disk, hard disk. Yes, can you tell me, guys, what's the difference between RAM and hard disk here? RAM and hard disk difference. Yes, RAM is a temporary memory, right? RAM is a temporary memory. Hard disk is a permanent. Yes, permanent storage, right? Hard disk is a permanent storage to store data, right? Yes, RAM is to process data. So RAM is for data processing. RAM is for data processing. RAM is for data processing. Yes, hard disk is for data storage. Hard disk is for data storage. Hard disk is for data storage. So RAM is a temporary memory. Yes, hard disk is a permanent storage. RAM is for data processing. Hard disk is for data storage. 1 second. Okay, fine. See, when you power on your system, so when you power on your system, first of all, power goes to BIOS, right? So as explained at the beginning classes. Yes, BIOS image. So this is BIOS, right, in our system. Yeah, this is BIOS, right? It's a BIOS. So once you power on system, first of all, power goes to BIOS. So this BIOS is responsible to boot your operating system. BIOS is responsible to boot operating system. See, hard disk. Inside of hard disk is a OS. Operating system. Operating system. Yes, inside the disk. Operating system inside the disk. Yes, OS inside the disk. See here, disk C drive, D drive. C drive, D drive. It's a hard disk for storage purpose. Hard disk is for the storage purpose. See D drive, all the files, right? Next C drive. Yes, Windows OS. Windows OS in the C drive, right? C drive. So once you power on system, first of all, power goes to BIOS. So this BIOS is responsible to boot your system. BIOS is responsible to boot your system. So what is booting process? So booting is a process of yes, loading ways from hard disk to RAM memory. So here it's a hard disk, right? Inside of hard disk there is a OS. That OS loading hard disk to RAM memory. See inside the OS, C drive, here it's a Windows OS, right? Windows OS. So here, once you power on system, yes, BIOS will load this Windows OS into RAM memory. Right? Loading Windows OS in RAM memory. See, here Windows OS running here, right? Where is running in RAM memory? Windows OS running inside the RAM memory. So here Windows OS running in the RAM memory. Right? So initially, OS loading from hard disk to RAM memory. Loading from hard disk to RAM memory. Right? Once loaded into system hard disk RAM here, system is ready. System is ready. Okay. Yes, operating system. So once loaded into RAM memory, your system is ready. Right? So OS loading from hard disk to RAM memory is a booting process. Booting is a process of loading OS from hard disk to RAM memory. So once booting is done, your system is ready. So this OS is running in the RAM memory. OS running in the RAM memory. Now this OS is responsible. This OS is responsible to run our request. Every request by the OS. Okay, right? Yes. Now let us see about Java program. D colon, yes, DER, suppose CD, some test folder, CD, test folder, CLS, clear the screen, test folder, D drive, test folder. Okay, yes, here. So for example, some program, notepad, yes, test.java, test.java. How this program is working? Let me explain clearly. The public class test, public class test, yes, in this public static void main, public static void main string, yes, area of arguments, square bracket args, string area of args. So main method starting, ending, yes, system dot, yes, out dot println, system dot out dot println, hello world. Very simple program. Yes, how JVM working on this program? That is our topic. Hello world. Save it. Save and close. Save and close. Now go to command prompt. Yes, at the command prompt, check it here. DER. See test.java file, right? Just now created. See the timestamp. Just now created. Java C. Compile it. Java C test.java. Compile, right? After compilation, check it here. Test.class file, right? Test.class. Now submit that request. Java test. That's it. How it's working. So Java test. Java means is a JVM. See, first of all, compilation Java C test.java, right? So this is Java compiler. Java compiler compiling your Java program, right? Next Java test. Yes, Java test to run the program. Java means JVM. See, once you submit a request like this, what happens here? This request simply goes to OS. This request at the command prompt request goes to OS. If that request goes to OS, right? Now OS is receiving your request. So OS simply receiving your request. On receiving request here, OS it allocates one memory space. OS creating that memory space. In RAM, yes, OS first of all creating one memory space. After creating memory space, then loading Java means JVM into that memory space. OS will load Java means JVM into that memory space. So OS is loading JVM into this memory space. JVM loading this memory space, right? Half loading JVM here. Now JVM takes test.class file. Okay, JVM taking test.class file, loading into this space, and it will run it here. Now topic is how JVM, yes, how JVM will work on test.class file. That is today topic about JVM topic, right? Not in a Java program. Suppose if you're running some C program exe file, even for C program exe file also one file, yes, one memory space creates. So test.exe file loading into this memory space. So Zoom application running in my system, Zoom application for Zoom purpose, one memory space. Like this for every, yes, application, every program separate memory space creates. Suppose Word document, for Word document purpose, another memory space. For Word document, another memory space. So Notepad running, for Notepad purpose, another memory space. Notepad, right? Notepad. Like this for everything separate memory space creates. Now this memory space, suppose Notepad. Suppose this data. See this data generating in Notepad, right? Notepad. This Notepad data generates inside of this memory space. Next Word document data generating here. Zoom data generating here. C program exe file data generating here. So this memory space to generate data. Next Java program running this, right? Suppose Java program running any data, Java program generating any data, it's generating here, storing inside of this memory space. I think it's clear. Suppose C program execution completed. Yes, OS clears that memory space. Once it completed, clearing that memory space. So before going to run any program, first OS allocating memory space, loading program into this memory space, and utilizing that memory space here. Once it completed, yes, that clears. OS will clear that memory space. So Notepad, Yes, notepad closed. Yes, OS will close that memory space, clearing that memory space. Our Word document closed, clearing that memory space. So Zoom application stopped, then closing that memory space, right? So Java program completed, then closing that memory space, clearing that memory space, right? That's it. So before going to run any program, so first of all, we is allocating memory space, then loading program into that memory space, then then running, right? Yes, now our topic is how JVM is working at java.class value. So this is our topic here. Yes, let us see. Let us see about this. Yes, Java program. Suppose test.java. Test.java. Yes, taken by Java compiler. So Java compiler generating test.class. So you can first test.java. Java compiler taking .java file, converting to .class file. So generating .class file. Yes, after generating .class file, then execution. Yes, for this Java memory space. Here this is, this is Java memory space. Yes, it's a Java memory space. Okay, so first initially .java compilation generating .class file. So this .class file, yes, Java test, right? Java means JVM. So first of all, JVM loads into that memory space. JVM loading into this memory space. JVM loading this memory space. So what is exactly JVM? See, JVM is like this. Yeah. So this is complete JVM. Class loader, bytecode verifier, interpreter, JIT compiler, garbage collector, thread scheduler, and security manager. So there are totally 7 components. 7 components working together is a JVM. All these 7 components collectively working like a teamwork is a JVM. It's a virtual machine. Java virtual machine is like engine. It's like a bike engine or some car engine, right? Let us take car engine. In car engine, so many components, right? Like yes, like piston, cylinders, inlet valve, outlet valve. Like that, there are many components working together is engine, right? So many components working is a engine. Same. Yes, JVM is like an engine. It's an engine. The JVM contains components like this: class loader, bytecode verifier, interpreter, JIT compiler, garbage collector, thread scheduler, and security manager. And this is complete JVM. JVM contains all these 7 components. JVM contains all 7 components, right? So when you submit it, the request like this. For this request purpose, first of all, yes, allocating memory space like this. After allocating memory space, then loading JVM to this memory space. Loading JVM. Loading JVM is all these 7 components that complete engine. Complete engine loads in memory space. So once you submitted, yes, request here. So first of all, creating memory space, then loading complete JVM. This JVM, complete JVM loads into this memory space. Right? All the 7 components. In these 7 components, so first one is class loader. First one here is a class loader. First one class loader. So first one class loader. So first of all, class loader. So first of all, class loader. Yes, in JVM, first step is class loader. Simply class loader. Yes, taking tested.class file and loads in this memory space. Class loader loads the tested.class file into this memory space. Okay, see this Java test one. See this could not find or loads main class test, right? No class loader. Class loader, yes, checking for test1.class not available. The class not found exception. Okay, unable to load it, right? Yes, this exception is from the class loader. Class loader throwing that exception. Okay, right here they say tested.class. Tested.class, right? Yes. So for tested first initially here class loader, yes, sorry, tested, Java tested. Class loader looking for tested.class, yes, available, then loading into memory. Class loader loads the dot class file into that memory space. So initially loading dot class file. Yes, fine. Yes. So first the class loader. Class loader loads the dot class file into this memory space, right? Memory space of loading. So next the component. So next is bytecode verifier. Next component, yes, bytecode verifier. Bytecode verifier. Shortcut. We can call as BCV. BCV shortcut BCV. Bytecode verifier. Right? Yes, it's just a dot class file taken by bytecode verifier. So bytecode verifier checking byte by byte, top to bottom, complete dot class file. It checks whole dot class file. So top to bottom, checking byte by byte. If everything is fine, then yes, if everything is fine, the test dot class file given to yes Java interpreter. So next Java interpreter will come to picture. So next is Java interpreter. Java interpreter. Java interpreter, right? Interpreter. Okay. So here what happens here? Class loader loading dot class file into memory. The dot class will be given to BCV. So BCV simply yes, it checks the whole dot class file and pass into interpreter. Now interpreter role starts. Yes, what's the task of interpreter here? Now interpreter converting bytecode to binary code. See, suppose Java program, first statement, next statement, yes, next statement. Okay, yes, like this, some statements. Java program statements. Right? Yes, here how it's working here. Interpreter. Yes, taking your dot class for first statement. Yes, converting into binary format. That interpreter converts your Java bytecode to binary format. Zeros ones format. Okay, so binary format, zeros ones format. Okay, so interpreter converting bytecode to binary format. After converting it to binary format, next what happens here? See in your system, some layers like see computer. Yes. See, in a computer, there is a hardware layer, right? Hardware. Hardware, OS running. At the beginning classes, you have discussed about this one. Yes. Operating system. Operating system, right? Operating system. Yeah, that OS contains library. Yes, OS contains library. Library. Okay, first hardware. Hardware is OS. This OS contains library. See, library, yes, already linked with hardware components. At the time of booting OS itself, that OS library linked with hardware components. Okay, fine. Now here interpreter taking bytecode, converting to binary format. After converting to binary format, yeah, that binary format simply links to OS library. So once linking with OS library, then program executes generating output here. Simply output transfer to output device. That's it. So this is what is happening here. So next interpreter taking second line. Okay, simply converts into binary formats. The binary code linking with OS library. So once linking with OS library, then communicates with the hardware. So what is happening here? So first error checking with Java compiler, right? Generating dot class file. Error checking with Java compiler. But runtime interpreter. Interpreter is a part of JVM. Java interpreter is a part of JVM, right? So errors checking with the compiler. Yes, error checking with the compiler. If no errors, generating dot class file. The dot class file executing with Java interpreter. Yes, Java depends on both compiler and interpreter. Same this term. Yes, beginning classes we have discussed. Java depends on both compiler and interpreter. So error checking with the compiler, program execution with the interpreter. So interpreter converting bytecode to binary code, linking with OS library. So once linked with OS library, generating output. That's it. I think it's clear. Okay, fine. So this is the first version of JVM. It's a first version of JVM. Yes, in next version of JVM, Next version of JVM is GT compile added. So next component GT compiler. Next version of JVM GT compile added. Yes, what's the task of GT compiler? See, so in first version of JVM, interpreter converting converting the source code to converting byte code to binary code. So first task converting this byte code to binary code, right? So what is next task here? This binary code simply linking with OS library. Yes, in first version of JVM, interpreter will perform two jobs. So one is to convert into binary code and linking with OS library. It's a first version of Java, first version of JDK. So first conversion task and linking task, both are by the Java interpreter. So Java interpreter performing conversion task and linking task, two jobs. Next version of Java, JDK 1.0. Yes, sorry. Next version, JDK 1.1. JIT compiler added. JIT stands for just-in-time compiler. JIT means just-in-time compiler. What's the task of this one? Let me explain clearly. See in this. So first of all, Java interpreter converting this byte code to binary code, right? That binary code simply pass it to JIT compiler. JIT compiler, right? Now JIT compiler taking this binary code, linking with OS library. That means two jobs were separated. The jobs were separated. Okay, right? So conversion task by the Java interpreter, yes. Linking task by the JIT compiler. So that is separated and parallelly working. So previously one after another one. So before JIT adding to JVM, yes, two jobs by the interpreter. So conversion task and linking task by the interpreter only. So one after another one. So taking some time, right? Yes, next version of Java, JDK 1.1, JIT compiler added. After adding JIT compiler, the jobs separated. Two jobs separated here. So first one, interpreter, converting byte code to binary code. Next, JIT compiler, linking this binary code with OS library, right? Yes. Now what happens here? First statement converts into binary code and given to JIT compiler. So JIT compiler taking first statement and convert, yes, linking with OS library. At the same time, say by the time of linking this first statement to OS library, second statement is ready. Now interpreter will convert second statement to binary code. So what happens here? See, suppose JIT compiler linking first statement with the library. At the same time here, interpreter works on second statement. So you get conversion linking task happening parallelly. The two jobs happening parallelly here. Two happening parallelly here. So see here, suppose interpreter working on the first statement here, first statement, then yes. So interpreter first initially working on first statement, then linking with OS library. Okay, suppose here JIT compiler working on first statement, interpreter working on second statement. If JIT is on first statement, interpreter is second statement. Suppose if JIT is second statement, then interpreter is on third statement. If JIT is third here, interpreter fourth statement. That happens parallelly. So what happens here? That improves speed of application. Speed of application. So what's the purpose of JIT here? JIT compiler. JIT. Yes, JIT stands for just in time. Just in time compiler. Just in time compiler. Okay. Yes, JIT. So why JIT added here? JIT added to improve the performance of JVM. JIT added to improve the performance. Improve the performance of JVM. Right? So just-in-time compiler, JIT stands for just-in-time compiler. Yes, JIT added to improve the performance of JVM. JIT added to improve the performance of JVM. That's it. Okay, right? Yes, next. Yes, apart from that, other components. See in this, what is happening here? First of all, class loader. So this one, loading dot class file into this memory. Right? After the dot class file taken by bytecode verifier, BCV, byte by byte checking. If everything is fine, then interpreter, pass into interpreter. Right? So interpreter converting bytecode to binary code. That binary code linking by JIT compiler to the OS library. Right? JIT compiler. Right? So they are the components in this. So you can class loader loading dot class file. bytecode verifier, checking byte by byte for validity of your dot class file. Next, interpreter, converting yes bytecode to binary codes. Next, GT compiler, binary codes, linking with OS library. Right? Yes. Apart from this, other components. Thread, scheduler. This is for thread management. Suppose if Java application is a multi-threaded application, right? Multi-threaded. That case, thread scheduler will manage all the threads. Yes, thread scheduler. Just it's a one component in the JVM. This one component in JVM, right? So this will take care of threading. Yes, in multi-threading, I'll explain very clearly. Right? Next, one more component, garbage collector. Garbage collector. In Java, this is a garbage collection concept. Okay. Yes, in Java, if any unused memory space, that has to clear. Any unused memory space with data, that unused data has to clear for this garbage collector. Garbage collection later we'll discuss. It's separate session. Yes, it's a 1.5 or 90 minutes class about garbage collection. Practically, I'll explain later. Right? And next, so one more thread, security manager. Yes, security manager. So this is to provide the security for Java applications. Security manager. Yes, about security later we'll discuss. Java security later. Okay. So this whole thing is a JVM. This whole thing is JVM, right? So how many components in JVM can? Yes, class loader. Next. So bytecode verifier. Right. Next. Yes, Java interpreter. Next, thread scheduler. Next, garbage collector, and then security manager. And next, GT compiler. So totally how many here? 7 components. All these 7 components working together like a team. It's a JVM. So this is JVM steps. So JVM, yes, it's a collection of 7 components working together. JVM contains 7 components. So all are working collectively is a JVM. That's all about JVM. Okay, right? Yes. Yes, the same topic it's in document here. Just you can follow document here. Same explanation. It's there in JVM. Yes, interpreter, GT, garbage collector, and all these, right? Okay. So that's all about JDK, GRE, and JVM.